Okay, I thought I'd give you a quick guide to finding the derivative of a function using the definition of a derivative. So let's imagine that we're going to be differentiating this function here using the definition of a derivative. Well, let's write down what that definition is. Remember, it's given in terms of limits. And it's the rise over the run. In the limit, as the slight difference between x and x plus h is allowed to tend to 0. So this is just a standard limit. We know what f is. We know how to calculate this whole thing. The only thing that tends to give people problems is just thinking about this. What is this f of x plus h? So let's just start a new page and have a chat about that briefly. So remember, our function is this. This is a rule for telling us what to do with the input. Whatever input you're given, you square the input, then you add on the input, and then you add 1 to it. And that gives you the output. So what happens if I say, what is f of y? Well, we take the input, which in this case is y, and we follow the rules. The rules say whatever the input is, square it, add it to itself, then add 1. Our input is y, so here we put y, and here we put y. But this rule works for anything, you know. If I don't know, what if this is a diagram of myself, looking cool. If I give myself as an input, well, the rule tells me that I must square myself, assuming I'm in the domain of my function. Add on a copy of myself, and then add 1 to that. Of course, this doesn't really make that much sense, but the point is that we're just following the rules of f of x. We're doing exactly what it tells us to do. So now, what if the input is x plus h? Well, we follow the rules. We take the input, we square it, we add on the input, and we add 1 to it. And in this case, the input is x plus h, and this is what f of x plus h is. Now, of course, you know, we can expand this. You know, we can turn this into, this is x squared plus 2hx plus h squared. And then we've also got this plus x plus h, and this plus 1. So we don't have to stick with the way it's originally written. But you see, there's nothing confusing about this kind of notation. If you just take whatever the input is, and then follow the rules. So, let's go back to our original problem. This means that we're going to be trying to calculate the limit as h tends to 0 of x plus h squared plus h plus x plus h plus 1. Okay, remember that's our f of x plus h. we're going to be subtracting f of x and then we're going to be dividing everything by h. Now, that's pretty easy to do, right? Okay, so let's move on to a new sheet. I've got the old line there. Right, let's expand that top. So we have the limit, so h tends to 0 of, right, x squared plus 2hx plus h squared plus x plus h plus 1, and subtracting from that x squared, x and 1, and all this is over h. Now what do we notice here? We've got an x squared and an x squared, this x, this one and this one, and they all match up. And so what we're left with then is the limit of 2hx plus h squared plus another h, and all that is over h. Now, what do we notice? We've got an h in every term in the numerator and we've got an h in the denominator, so let's just think about that. We can factor out the h in the numerator and factor out the h in the denominator, and they will then cancel. We'll be left with the limit as h tends to 0 of 2x plus h plus 1. Now, let's have a think about this limit. What happens? As h tends to 0, 2x is completely unaffected by h. So 2x, just in the limit as h tends to 0, is equal to 2x. Sorry. Now, the limit as h tends to 0 of h is going to be 0, and in the limit as h tends to 0 at 1, it will just remain as 1. So, what we're left with then is that this equals 2x plus 1, and so that tells us what we already knew, that df by dx is 2x plus 1. And that's how you differentiate from first principles. In other words, differentiate using the definition of the derivative.